Okay, let's look at an example of sketching the graph with slant asymptote, right? Slant asymptote. So here's an example, right? So say f of x is equal to x plus 4 over x, right? So we want to find the slant asymptote, right? And the first easy one to find is vertical asymptote. Vertical asymptote is going to be x equals 0 because that makes the denominator equal to 0. So x equals 0 is vertical asymptote, right? And also horizontal asymptote. In this case, if you take the limit of the function as x approaches either positive infinity or negative infinity, it's going to be infinity. There is no horizontal asymptote, right? But there is something called slant asymptote, right? Let's look at this. You look at the original function and try to see what happens to this function as x gets larger and larger, right? So for large x, right, you can see that this second term, if x is a big number, 4 divided by big number, this guy is very close to 0, right? So you can see that this function is very much similar to just having x, because this term is going to be very small. So this is very close to x, right? So for a large x value, original function behave just like y equals x, and that is called slant asymptote or oblique asymptote, right? So y equals x is going to be the slant asymptote. Alright, so let's go ahead and sketch the picture using the technique we just learned in the previous video. Alright, so let's take the first derivative. So derivative is going to be f prime of x is equal to, right, derivative of x is 1, right? And 4 over x can be rewritten as 4 times x to the negative 1. So derivative is going to be negative 4 x to the, subtract 1 from the power, so negative 2 power, which is going to be equal to 1 minus 4 over x squared. And if you want, we can take the common denominator. You can write it as x squared minus 4 over x squared, right? Then we can factor out the top, which is just x plus 2 and x minus 2 over x squared, right? Let's set that equal to 0 to find the critical value. So that's going to be, right, x equals negative 2 and positive 2. So x equals plus or minus 2, right? So those are the critical numbers, critical values. Alright, then we can do a number line on this, and let's quickly do that. So here, let's do a number line for f prime. Alright, so x equal to 0, it's not defined there, and also plus or minus 2, those are critical values, so negative 2 here and a positive 2 there. Alright, then we look at the sign, right? So we can look at anything smaller than negative 2, so we can try negative 3, right? So if you put negative 3, you see that the negative 3, so that's going to be negative, right? So negative 3, so that's going to be negative, right? And then here, this guy is always positive because of the square. So negative over positive is going to be positive. All right. So we have the positive sign here. All right. Between negative 2 and 0, we can try f prime of negative 1. All right. Then negative 1. So negative 1 plus 2. So that's going to be a positive sign there. All right. Negative 1 minus 2, that's still negative. This is positive, so you can see that it's going to be negative there. Alright. And how about, How about the between 0 and 2? So we can try 1. Alright, if you put 1 here, so this is going to be, I'm going to erase it, it's kind of hard to see. Alright, so this is going to be positive. It's going to be positive. Alright, 1 minus 2, that's negative. Alright, this guy is always positive. Alright, so it's going to be negative there. Alright, how about when x is bigger than 2? So we can try 3. Right? So you see that 3 plus 2 positive, 3 minus 2 positive, and bottom is positive, so everyone's positive. Alright? So we have that. Oops. Right? Right? So we notice that we have increasing, decreasing, and a decreasing, increasing picture there. Alright? So let's take the second derivative as well. So let's look at the second derivative, f double prime of x. Right? So this is going to be derivative 1 is 0. Derivative of negative 4x to the negative 2 would be positive 8x to the subtract 1, so it's going to be negative 3 power. So you have 8 over x cubed. Alright, then we can do a number line, and the only tick mark that we can put is 0. Right? So if you put, let's say, so it's just for the second derivative. Right? If you look at the second derivative of negative 1, you see that the 8 over negative 1 cubed is going to be negative. Right? So you have a negative sign here. Right? And if you try something positive, so we can try 1. 8 over 1 cubed is positive. Right? So this is positive. Alright. So we have that, and we know that this is going to indicate, right, for the original function here, it's increasing, decreasing here, and increasing here. Oh, sorry, that's decreasing. Alright, so decreasing here and increasing here. And also concavity wise here, concave downward, here concave upward. Right? So let's try to sketch. Right? So there is let's see, a vertical asymptote right here. So I'll just draw that. So vertical asymptote, which is the same thing as y-axis. So vertical asymptote here. And there's a slant asymptote, which is y equals x, so which is this guy. Right? Go through the origin, and the slope is 1. Right? So this is slant asymptote. Equation is y equals x. Right? Then we have to have following shapes. Before we sketch the picture, I would like to have some points. So let's see, I'm going to look at the critical value, x equals say 2. So say somewhere around here. So 2, and x equals negative 2. Right? I'm going to find a corresponding y value. So I'm going to do f of negative 2, for example. It's going to be negative 2 plus 4 divided by negative 2, right? Just plugging into the original function, and that's going to be negative 2 minus 2, so it's negative 4. Right? So we can do f of positive 2. So you have a 2 plus 4 over 2. Right? 2 plus 2 is 4. Right? So you can see that this is going to be negative 4 around here. So we can place a dot, right? And positive 4 probably around here. And we can also place a dot there. So I'm gonna use this color. So here's I have to go through there, and I have to go through there. All right, let's try to sketch the picture. All right, so on the first interval from negative infinity to 2, it has to be increasing at the same time concave down. So it's going to look like that, and you have a slant asymptote. So it's going to look like that. Alright, after that it's decreasing and it's still concave down, and you have a vertical asymptote. So it's going to look like this. Alright. And between 0 and 2, it's decreasing and concave up. So it's a vertical asymptote there, and decreasing and concave up. Right? After that, it's an increasing and a concave up. So it's going to look something like that. Then you have a slant asymptote. Alright, so this is the graph of y equals x plus 4 over x. And you can see that as the x value gets larger and larger, it is getting closer to this slant asymptote. Also, as x approaches negative infinity, it approaches the slant asymptote as well. Right? So let's double check to see if how well we drew a picture by using a software to sketch the same graph. Right? Alright, so using GeoGebra again, and I'm gonna sketch the graph of y equals x plus 4 over x. Then hit enter. Alright, so this is the graph. Maybe we should zoom in a little bit. I'll actually zoom out. Well, that's what I meant. Zoom out a little bit. Alright, then move it a little bit. So this is the picture. Alright, then if you want to see the slant asymptote, which is y equals x, which goes right here. So you can see that the graph is getting closer to slant asymptote as x approaches positive infinity, and as x approaches negative infinity. Alright, so if you look at this picture, right, so we did a pretty good job. Alright, that's it. I hope that this was clear.